Hello everybody, welcome back to another edition of the EcoStruxure Machine Expert training. I'm your host Leandro Humada, and in this video we're going to talk about the input and output variables that we have in the software. So let's go to the software. So we have seen in the past the GBLs and the local variable that we have in the views. Now it's time to focus in the input and output variables that we have. So in this case, I'm working with the M251. For those who don't know, the M251 doesn't have any inputs and outputs, so we need to add some IOs. In this case, I'm going to go into here in the IO bus, add some function blocks, some modules. So I'm going to use this one for outputs, and then I'm going to use an input TM3. Okay. There we go. So in this case, we have, I have two of this. Okay, so in this case, I have TM3 IOs, variables I'm going to have here. But if, for example, you're using the M241 or M262, you have already some embedded IOs. So if I add, in this case, I have this M262. If I go to digital outputs, you can see here that you have some outputs already embedded. Okay, you have in this way, which is icons over here, digital input with the arrow coming in and the digital outputs with the arrow coming out. So as you can see here, all the variables that you have, or all the inputs and outputs that you have on the controller, the embedded IOs or in the external, have an address, okay, which is this one. Okay, with the start, if it's input, it will start with the percentage I, and if it's an output, it would start with the percentage Q. Okay, and then if you have a combination, or you're using an analog variable, it will start with the percentage IW for word, or percentage I percentage QW also for word. Okay, and for the individual bits or digital inputs and output that you have, it will start with the percentage IX or percentage QX, meaning that for Boolean variable that we have in the system. Okay, so that is basically the idea. Okay, so if we're going back to, for example, you need to close this one, go to the full view now. If we have, for example, the TN3, I'm going to use the output here and here. Okay, so in the IO mapping that you have over here, you can see by default that we have this name over here. And if you go to the input, you can see this name over here. Depending on the amount of IOs, probably you can find percentage I or percentage B for byte, okay, depending on the amount of variable that we have. So in the program, okay, you can use the address, okay, let me just vertical. Here you can see they have this program. Let me just delete it. Okay, let's start fresh. So I can easily start with percentage IX 0.0, okay, which is valid, is this one. Okay, let me see if I can see the description over here. Hello. In order to see the description, that is easy. Options. Here, ladder, we can see more information. Comment. Okay, we're gonna see that how is the behavior now. So this is how you can address this variable, okay, to this one, to the input. The same can be applied to the output. So here, world, you can use this percentage Q 0.0. So in this way you can percentage QX 0.0. So you can activate the output in this way. Okay, but to be honest, in Machine Expert, there is no mandatory to use the address. Okay, we can use symbolic, as you see over here on the GBL. Okay, there is no mandatory to use address. Okay, percentage MW, percentage MX, or percentage MD for different kind of variables. We're going to cover that later, but it's not mandatory because the system works with symbols. So we can also assign symbols to the inputs and outputs in order to use those symbols in the program, and we can easily identify what are we doing, because if I see this percentage I x0.0 and the output percentage q x0.0, it doesn't mean anything for me because I really don't know. That's why it's much better to use the symbols. So here is something that we need to know. I don't remember if it's in the input and output part. It doesn't allow you to enter, but in this one. So in the output, if you receive this message, okay, it means that you cannot assign a symbol for the complete block when it's already assigned in here. Okay, so for the outputs, we already have a symbol, which is this one, QW model, blah, 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 blah. But what we can do is to delete that. So I can easily delete this and work with this variable over here. So here I can define, for example, Q lamp. Okay, and instead of using the lamp red, for example, instead of using the QX and the address, it's going to be a nightmare, I can easily use this, the Q over here. It's going to be much easier. And we also see that in the description and everything. And the same can apply to the input. But for the inputs, it's a little bit different because here, input, we can double click and assign something. So this one should be I button, okay, and I can use this over here, and that's all. And I can see the description and everything. It's going to be much better if you want to read your code. It's much better in this way. Okay, now this is how you can do it. This is one way to do it, but there is another one using GBL, that you can assign the input that you have into the GBL. So let me just show you how it can be done. So if I want, I can create a new GBL. Okay, for example, GBL underscore IO add, and I'm going to specify here button or button red. Okay, and I'm going to specify another one for Q lamp red. Okay, so I'm going to link these two variables on the GBL to the IO card that I have. So let's start with the output. So instead, you can see here that it's mapping, okay, and we have the address. So if I, instead of using this, let's change the name. Here is this GBL. I'm going to assign, instead of blue, let's start with red, blue. Okay, yes, I'm going to change this in there just to show you how it's done, or how it can be done. Okay, good. So here I can click over here and I can see this three dot button. Click over there. If we go to application, we should be able to see the GBL, and we can select the variable that we have. So this one is an input, so I'm going to select this one. Okay, and pay attention now on the address. It's Spanish. Okay, so the mapping icon also changed because this one, now this physical input that we have, this physical output, okay, just change this to lamp blue. Okay, this physical output now is linked to a GBL variable. So we, instead of using now the Q, the percentage Q that we have on the variable, is linked to a GBL, just only using the symbol. which is fantastic, because now we can delete. Imagine that you have a TM3 module. You can delete the TM3 module and the configuration of the variable, okay, or not the configuration of the variable, the assignation declaration of the variable is already defined in the GBL and it's not lost, okay, in case you need to delete the module. And if you use this GBL in your logic, it's already in there and it's not gone. Okay, so then you can change the TM3 model and you can assign then the variables over there. Okay, so that's good. And the same can apply to the digital inputs. So I can assign this button blue. Okay, you can see here the address is no longer available. And in order to use this in our program, as I explained before, we just need to create just over here, just double click over here and add it into my program. Okay, here we just need to define the GBL name that we have, GBL underscore IO dot, and we have the functions button, and the same can be applied over here, GBL underscore IO dot cube lamp. So in this way you like map into the GBL all the IOs that you have. So in the future you can just easily change the TN3, okay, and the logic on your program is going to be static, because for example you already have this already assigned, okay, but I also have these two variables at the beginning, okay, and so if I disconnect over here and imagine that I'm using that in my code, okay, I'm going to receive an error over here, and which is good because I have deleted the module. But here in the program, these two variables that was linked to a TM3 module, we don't have the error for those variables because are already assigned over here. So I can easily define another TM3 module, for example, a mix for inputs and outputs, okay, for example this one. And here what I can easily do is to assign those variables I have created before. Okay, let me just reset mapping. Okay, so I can start fresh. The inputs, I can assign the input I already have, button blue. Okay, and I can assign the output over here, lamp blue, and it's going to be executed. So that is one of the good things that you can do with the GBL once you have the IO mapping. That is what you can do, and the same can be applied later when we see, for example, the IO scanner, that we're going to create some Modbus mapping, something similar to this, but we're going to focus that later. So this is what is important to know, the different IO variables that we have and the GBL, so we can work properly on the software. So thank you very much for watching this video, and I see you on the next one.